Good morning, everyone. Thanks for taking the time today morning at 9:30 to attend our Industrial Metaverse panel discussion. I think we have a great lineup with leading industry experts, and we will cover 4 key questions in the next 30 minutes. First, we will bring a little bit light into what is the Industrial Metaverse and how the Industrial Metaverse goes beyond a digital twin. Second, we will talk about the technology base. So what kind of new enabling technologies are needed to turn the vision of an industrial metaverse into reality? And last but not least, we will share with you industry best practices and lessons learned from the industry. But first thing first, let me briefly introduce, and please join me in welcoming our industry experts. From the left to the right, Max Cavazzini from AWS.
Good morning, everyone.
Matt Chan from Delta Electronics, and Timo Kistner from NVIDIA.
Morning.
And Stuart McCutcheon from Siemens.
Hi, everybody.
Gentlemen, when talking about the industrial metaverse, I think you will agree that digital technology overall impacts the world of manufacturing since decades. If we think of computer-integrated manufacturing, impacted the world of CNC machining. Industry 4.0, by the way, a term which has been announced first time here at Hannover in 2011, helped us actually to unlock OEE potential and brought data analytics to the shop floor. And also the IT world, let's think of, we leverage deep learning to enhance robotic applications. But nevertheless, there are still problems and challenges along the factory lifecycle, especially when it comes to interoperability. Maybe Stuart, a first take from your end. How can the industrial metaverse help to overcome the interoperability challenge along the factory lifecycle?
So, the goal of the industrial metaverse in my mind is like to try and create this transparency layer across the top of all these information systems. Over time, we've developed many IT systems, MES, IoT, PLM, and really is how do we bring the real and the virtual information together in a simple way, right? And really breaking down those barriers, you say, of this data operability. But you have to bring the data together in a precise manner, right? Right versions, right time, all this information needs to be synchronized. And this is the challenge that the industrial metaverse has to solve, right? At Siemens, as part of our accelerator portfolio, we have tools and technology within that. And we're leveraging partner technology from AWS and NVIDIA and things to sort of overcome some of these things. But it's really how do you create this transparency layer over this data, right? And that's our goal, of what we're trying to achieve with the industrial metaverse.
Excellent. Maybe, Timo, if we connect to what Stuart explained, what is the role of OpenUSD, so the universal scene description format?
Yeah, sure, absolutely. Like you said, right, it's all around combining massive engineering data sets, right, and how do we bring that together? It's all around having a uniform standard also, right, and this is where universal scene description comes into play, right? For us, this is the closest to a 3D standard, actually, right, and we see this as the standard, like you can compare it with HTML for the internet, right? USD is going to be the standard for 3D environments, right? And the nice thing about that is it's not only for 3D scenes, 3D words, you can really combine it with all kind of data, machine data, for example, building information data, right? It's pretty much of a universal standard, right? And so from our perspective, developing this standard further into something that really can cover all the different industries out there together with our partners, right? We founded the Alliance for OpenUSD to really develop this standard further. This is really important, and this is going to be the core basis of the industrial metaverse.
And we joined the USD to actually give that industry flavor and those elements to it, can put that engineering context, because that's what the industrial metaverse needs. USD for us is standard that goes well beyond what we do in PLM or our engineering world. And it really gives us that higher view of being able to put those global scenes together, which is really important.
Yep, absolutely.
Can you share an example who is using USD, so some areas of application?
Do you want to?
So we are now we're at the early stages of integrating USD within our portfolio. Actually, on our booth over there, you'll see a product that will be released at the end of this year, where Team Center X, our Team Center solution, will actually have a USD embedded dynamically in it. So we have a JT format, which is lightweight engineering format, and bringing JT and USD together in this engineering format is our goal in a very seamless way. So you can configure a bill of material, you can look at it in a photorealistic world within USD. This is really where we want to go. It takes ours to the next level, and we're using AI and technologies to create scenes around this data as well to take it even more realistic. And that's one of our goals.
And I think if you look into that example, right, we're talking how many? 7.5 million parts?
Yeah, so the ship example we have is Hyundai ship. It's a ship with 7.5 million parts. And then actually in the scene, we actually put it in a shipyard, which has another like 15 million parts. So that scene is massive, right? And that's really why we're partnering with NVIDIA to be able to do this in a ray tracing form.
And I think that's exactly what we're seeing now. Right now, we are able to bring those massive engineering data sets into one place, right? And again, USD is the basis for that.
Excellent. So the picture which we see in the back may be a thing of the past. So this challenge of interoperability, as I understand you, can be used with OpenUSD. And maybe just for curiosity to share with you, OpenUSD, by the way, is a standard which has been initiated by animation studios, by Pixar, right? Because they face similar challenges as we face in our manufacturing domain, because creating a fully animated movie you need to coordinate work across dozens or hundreds of animation studios. And actually to coordinate the work and to work on one movie at the end, they came up with the idea of USD. And now this USD standard impacts the world of manufacturing. And I think it's very interesting. For sure, we need to enrich the standard. We need to add physical material properties, IoT data. But at the end, it really helps us to address the challenge of how to work collaboratively in near real time in a heterogeneous industrial software tool chain. But I think the industrial metaverse goes even beyond improving the collaboration across application domains. So if we look into how new enabling technologies impacting the world of manufacturing, and I think what makes also the industrial metaverse kind of special is it embraces technology. And technologies out of the IT world as well as OT world. We see here a little bit a time frame, and I briefly mentioned Industry 4.0 was announced in 2011 here at Hannover Fair. But if we look back, and sometimes it helps to do a little bit of a retrospective analysis, there are so many new technologies out of the IT world which now impact the world of manufacturing. And I think generative AI is just one example. Also when we see how software-defined automation, cloud edge computing, all these technologies now impacting the world of manufacturing. Maybe we elaborate a little bit on what is the technology base of the industrial metaverse. Just thinking of synthetic data generation, photorealistic rendering. What's the role of this?
Yeah, I mean, like again, the basis of course is USD, right? Bringing all those different kinds of data sources together. But when we look at the broader technology base, right, be it machine data, be it robotics, be it AI, generative AI, of course, right, it's all around combining all these technologies, right? And from our perspective, like leveraging generative AI also to, like you said, use that to synthesize training data, to synthesize assets which you might not have yet in your CAD data that you want to combine, right? This is going to be a core part which makes the whole 3D workflow more efficient and more effective, right? And from our perspective, the combination of AI, embracing AI within the industrial metaverse, right? We're thinking in terms of like the next step of AI is going to be sort of a physical AI, where the actual asset, the virtual asset, understands like how am I interacting with the actual real world out there, right? This is where we need to bring all of this together. This is where robotics will play a major role. This is where the industrial metaverse can help train all those models virtually to a point where like, okay, now I have the accuracy that I need, deploy, off you go, right? And you don't need to go back and forth like you did before between your actual model and the real world. this is what you will do in the future, all in the metaverse.
Max, maybe we're talking about technology, and as we see, we need to embrace a lot of technologies. And technology needs to be managed, right? And I would guess not all these technologies are installed on premise. What's the role of the cloud in the context of the industrial metaverse?
Yeah, I think in general there is a lot more maturity on the customer side. I mean, if we go back when Industry 4.0 was invented, was everything on-prem, keep it in the plant. Then there's been a phase where put everything in the cloud. Now, reality is that if you start for the real use cases, you will have cases where data should stay near the machines. I think about a plant we are working with Siemens, where there is an MES running on an outpost, which is an on-prem AWS, which a few years ago wasn't possible. Now, the work we are doing with NVIDIA, it's making sure the right data are going into the cloud and you use the infrastructure, networking, security, high-performance computing to make the right choices. So I think there is a little bit of both where, I mean, a plant itself can produce petabyte or terabyte. What are the right data that should be there? And still there is a lot. I mean, we have 250 plus standards and protocols. So how do you contextualize? If a machine is running, the signal could be running on, working up. How do you contextualize them before you move them into the cloud to make the right choices at the right time? I think there was a good call out on the time and the context is relevant to make informed decisions, especially now where we see Metaverse really coming live with GenAI and the ability to really manage and compute those huge data to make the right choices. This is where we help, of course, on the infrastructure side, but I would say even on the tools, helping customers and partners to build applications that are solving. If you look around, 35 kiosks solving specific business challenges. It's not just about the underlying technologies, also how you make it easy for final customers and for partners to use those technologies, make them available.
Okay. You mentioned briefly also the term of accelerated compute, right? I think we live in a world of acceleration. I think NVIDIA is on a way of accelerated compute since 30 years. Yeah? What's the connection between accelerated compute and industrial metaverse? Is this a little bit the reason why industrial metaverse is possible today and not 10 years or 5 years ago?
Absolutely. That's the reason why we are talking about it today, right? And you're right, NVIDIA is all around accelerated compute, right? Everything that we do when it comes to training of AI models, right? When it comes to the industrial metaverse, you don't want to wait for a rendering like you see in the Teamcenter X demo. You don't want to wait for that like for 2 hours and then you have one scene and then you realize, oh, I need to do it differently and then I need to wait for another 2 hours. You want to have that in real time, right? You want to bring that experience to your customers in a way that they are able to really interact with that scene, jump through different viewports, different views, adapt that, interact with the assets in that scene, right? Without accelerated compute, without having accelerated compute scalable in the cloud, we wouldn't be able to really do that today, right? And we haven't had that like 5 years ago.
Yep.
And for us, you know, the industrial metaverse is about experiencing the digital twin, right? The real and the virtual information coming together. So I need to do that in a physics-based mode. I want to see simulation in real time in that scene of that asset, exactly what's happening. This is where you really need high power. You probably couldn't do this 5, 10 years ago. And this is the next level, right? So when we look at the industrial metaverse from a, you know, what is new, what's different, is think of this layer that sits on top of everything that lets you experience the digital twin. But the information, to be honest, is not all 3D, right? If you look at some of our demos and work we're doing, like 95% of it is non-3D data, right? So we basically need to be able to take that non-3D data and sort of position it and experience it in a geolocation. Okay. So you're trying to bring these two worlds together of this information pipeline to make it easy to understand. We want simulation that's normally locked away in expert roles in product development. We need to expose that so everybody can use it in a simple way. That's our goal.
So to make it more easable, more accessible also for people, so that you can use simulation in a much broader scope. If I'm listening to you, am I right that I think now we can claim, we can close the simulation to reality gap? Yeah? And I think we can also claim in future, a factory is born in simulation and working in reality, because we can now synchronize the real world with the virtual world, and it not only looks like in reality, we also do great enhancement, for example, in emulation of physical simulations, or when it comes to emulate physical behavior. I think this is also something which is part of the industrial metaverse.
Right. So what the goal is to give more insight to that physical thing. I want to use that virtual world to actually see more insight that you can actually see there in the physical world. That's the goal.
I think everything that we do, right? Whenever we talk about the industrial metaverse, keep in mind physics-based, right? It's not like whatever you might have seen in the consumer metaverse, right? But physics-based. We want to have a physics-based visualization, right? And we want to get to that point where we have a physics-based simulation. We want to enhance that with generative AI to make it even faster, right? And as you say, right, at one point in time, it should be 100% perfectly synchronized.
Yeah. So it sounds so great, but now I'm really curious to ask Matt, because these three gentlemen represent actually the tech giants of the world. So you offer the underlying infrastructure and a lot of services around this. We have the Omniverse platform, which is one of the core enabling layers and technologies, and for sure Siemens with the entire industrial software toolchain and automation tech, which brings it to life. But you use it. Maybe, Matt, can you share one or two examples where you applied certain of these technologies to really enhance productivity or achieve better planning efficiency?
Yeah, thanks, Tillman. First, I'm very honored to be here today to represent Delta Electronics, global leader in energy efficiency, power supply, and thermal management solutions. In this era of AI proliferation, we are committed to excellence in this area, not only to position us as industry leaders, but also underscore our dedication to sustainability and environmental stewardship. At Delta Electronics, we are very proud of we can deliver product and solution with exceptional performance, and we're driving toward to the energy efficient and innovational responsibility. I lead a team with Delta Research Center and focus on digital twin technology. The innovative approach enable us to help Delta to do some kind of job in product design and manufacturing. Then allow me to share an exciting use case with NVIDIA. This is focused on our production lines. Perhaps you know, in an intelligence production line, the first thing is you need to know where the product is. We want to know where the old product piece and all the time. Traditionally, there are two approaches. The first approach is you can put a sensor on the product, and you can use IoT technology to trace all the product. But unfortunately, in our scenario, our product is so small. Some of our products are very small, so there are no space to add any sensor to it. The second approach is you can put some camera and use AI vision analytics to train the object detection model to trace where the product is. As you know, AI training needs a lot of data. Collecting this data needs many cost. So our challenge is that. So our when we are facing these problems, we think if we can use digital twin, can we put virtual camera in the virtual environment and take a lot of photos to train the models. Our collaboration with NVIDIA Omniverse is instrumental on these topics. By leveraging NVIDIA Omniverse very realistic 3D modeling, we can get synthetic data. The synthetic data vary in lighting scenario, material, texture, angles, and position. The synthetic data can be trained AI object detection model.
Matt, let me just, because you're an absolutely expert on this topic, huh? Maybe let me a little bit contextualize what you were talking about. It's a great example of how can you enhance visual quality inspection by using synthetic data generation, right? Because the problem set is that especially at start of production, we lack training data. So without training data, we are faced with a high pseudo error rate in, let's say, standard machine vision systems. And exactly what you described, now what we can do is, because we have the CAD planning data, we have the ability of photorealistic rendering plus synthetic data generation, we can generate possible quality defects upfront in simulation, train our AI model, deploy this to the industrial edge, and then can inspect and identify possible quality defects at part number one. And this has a significant impact because normally you need to wait 6 weeks, 3 months until you have sufficient training data sets. And you see here also some numbers. Yeah? So we did this at a couple of client sites and could achieve around about a reduction of 40% in quality costs. Yeah? Because depending what you produce, if you produce products with defects and you ship these products to your end customer, it could be quite costly for you. And this is very concrete speaking where the industrial metaverse can help actually to overcome this bridge. But also what I think all of you also explained, like when it comes to the engineering processes. So we also see in industry great examples with around about 30% better planning efficiency by using OpenUSD as a standard, using Omniverse Nucleus connecting the industrial software toolchain trades. There are great examples out of the automotive industry. Look what BMW, for example, is doing. And also, last but not least, when it comes to robotic, and this brings us a little bit to the topic, I think all of you, if you have followed the news, there are really great new enhancements and news around robotics. And I think we can really claim that also the industrial metaverse impacts the world of robotics very much. So if we think of the world of simulation is turning into that we not only capture a picture with a machine vision system, in the next step we will work on building so-called causal models of the real world so that we can do concept learning, so that robotic systems are really capable to overtake handling operations, too versatile and complex for traditional automation today. And maybe, Timo, you also announced that the GTC, I think 2 weeks ago, an SDK where, let's say, each and everyone could actually build its own human robot, right?
Exactly. So, indeed, we believe the next wave of robotics is going to be about humanoid robots, right? So released that Project Groot. That's the foundational model for training humanoid robots, right? That's one part of it. There is a training environment using reinforcement learning, Isaac Lab, to really use all these different technologies in the industrial metaverse again to train those robots, right? And of course, there is accelerated compute behind, right? New processor generation that helps accelerate that. For us, that's definitely the next step that we're going to see. And for sure important because like robotics, all of the robots out there, right, be it humanoid robots, be it whatever other robot, right, they will be autonomous at one point in time, right? And this is exactly where we are providing the full stack down to the infrastructure to train it.
Max, we are here at AWS, and for me it's super impressive seeing this whole ecosystem you built up, yeah, with a lot of partners. what's your take on what kind of partners are needed in this industrial metaverse? For sure, it's you build the building blocks, but I think there will be also other partners which we need to bring to the table.
Yeah, how many hours do we have to go through all the partners that needed? No, I mean, I think there is really a shift now. I follow up on robotics. If you think the next gen robots will be, probably the first gen will be capable of semi-autonomous and working within people instead. They are going out of cages, right? Next step will be autonomous. Now, if you think about the entire metaverse, you mentioned, engineering, operation, supply chain, and such. I think that there are companies that are really getting what is the use case and the business value. This should always be the starting point, and then working backwards to the technology. So you go from, we didn't mention, cybersecurity, optimizing. I mean, when we think about using AI, we have been using AI for 15 years to optimize already high-performance computing, to optimize how we look at the data. Now, the next phase will really be how I can use less resources with the maximum result, right? So if you think about there is a CFD demo outside using an AI model to reduce the number of simulations you need to do. So on one side, we need more and more computing power and more storage. On the other side, we need algorithms to optimize the simulation. Same from generative AI. You have models that cost 1/10 of the other, and companies, customers will need to look really at what is the business case there and such. So partners that are understanding the world, that are really deep into operations, engineering, and leverage technology for getting a business outcome. This is I think the main philosophy we are looking at. And there will be niche partners or large partners like Siemens and NVIDIA, and we all together will bring the industry to the next gen. I think that's really key, that we really start from the customer, work backward to the technology. And then Matt mentioned sustainability. I think there's a lot of effort going on there. I mean, as AWS, we committed to be net zero 10 years before the Paris commitment, to be water positive in the data center. So I would invite also everyone to look at sustainability not just as a regulation coming where we need, but really as a task each individual should take to have, also bottom line impact. If you save 10% of water, it's sustainable, but also it's a bottom line saving.
Okay. Stuart, I think that's very much in line with the accelerator program.
So it's, we see the partner ecosystem is the essential thing to make this happen, right? If you look at our view of partners, we have the hyperscalers, the people that provide the raw grunt power, data consumption, manipulation of data. We have technology partners, both software and hardware, providing toolkits that we can leverage within our accelerator portfolio. And then we have deployment partners, our SI infrastructure, like BCG, to help teach our customers how to implement and deploy this. And without all of these together, even down the hardware, if you look at our stand, we're showing off this new technology from Sony. And they're, Sony and Qualcomm all coming together. It's all these different partners that really create this solution, right? But again, educating customers of how to deploy this is very, very critical in our world.
Great. So to put this a little bit into context and to put it into a nutshell, I think if we look for a definition of the industrial metaverse, I think for and foremost we could think the industrial metaverse is a persistent platform which serves as a digital replica across your organization and your operational processes. And I think for the first time it really embraces your product data, your manufacturing data, your planning data, as well as your people data. So it brings together the different data sources which are so important to steer all your designing and engineering processes. And last but not least, from a technology perspective, it embraces a lot of IT and OT technology. So the industrial metaverse is not a technology by itself. It's more like a concept, an architectural principle, how you can address four major or the major challenges in the manufacturing world. And this includes using existing standard technologies in the IT/OT world, but also new technologies like generative AI or synthetic data generation.
And for us, it's where you can make engineering decisions faster. That's the ultimate goal. Both, leveraging precise data from the real and the virtual world, experiencing that digital twin. That's what this goal is about. We're all running faster. We need to make decisions, accurate decisions faster.
I like this very much because if we just think of if everything turns into software, now we can really innovate at the speed of software, right? And I think this is one of the key challenges which we have today because the reality and working in a real world is often different to what we could simulate up front. And now we can close exactly this gap and just think of a world where you turned everything into software. You can emulate and simulate much more. And this at the end also accelerates all your development processes and should be the one who is actually embracing and understanding this should have a competitive edge versus competitors. Yep. Maybe we have now the chance to open up to the audience and see if you have any questions. Who's first, please? Do we have a mic?
Hello, everyone. I'm very honored to have the chance to be here. And first, I would like to echo our BCG experts' opinions. Thanks to the Industrial Metaverse, we truly believe the Industrial Metaverse can help us all to reduce the waste down to the minimum, to increase the productivity to the maximum. And another secret weapon is the traceability. Without the traceability, and also echo to Siemens expert, without the traceability, is no way to combine the virtual world and the actual world.
Correct.
For example, we are considered about the acceleration of transformation, acceleration of the technology. Consider to NVIDIA's animations. Without the acceleration features combined into the cartoon, there's no way for us to feel. For the industrial manufacturing, it's so important that we can handle not only the animation, the geometry simulation, but also the physical world. For example, Siemens make the best machine center in the world. How to make the parts the best? You have to not only the geometry contour, but also the force, even the torque, and the calibration with the compliance in order to make the best parts in the world.
Yep.
Okay, so actually I'm from data electronics, and there are many cases we are now doing, and including our service to NVIDIA and also Amazon right now, doing very hard. We are very hard using Universe to do all kinds of simulations. And what is the best benefit of NVIDIA contributing to this world? Based on USD. It's a universal scene data. It's a scene data. It's not just geometry data, right? It can combine acceleration. With the acceleration, then can show process simulation. It's very good news. Via the USD committee, we can also combine not only animation but process simulation. Consider how to reduce the gap between virtual world and the actual world. The process simulation must be done. How? And thanks to the ANSYS as well. They use the USD format and successfully to describe the process, thermal, temperature, all kinds of process, not only physical, but also chemical. That can be done based on USD base. That is a very exciting format protocol, allows all the engineers in the industry using different kind of tools.
Yeah.
For industrial engineering people using visual component, using FlexSync.
Yeah.
When they want to check with the real world, the cycle time is not real. Cannot promise to the boss, say, this order, if we take, we can make money. No way. So if we can combine
fully underlined.
reality,
Yeah.
then we got very good chance to reduce the waste down to the minimum and to increase the productivity. And furthermore, we don't need to back and forth, try and error with the simulation. And also, I need to be honest with you, before yesterday and before the day before yesterday, I stayed in Siemens booth for a long time, learning a lot as well. So the most important thing is if we human beings can work together, no matter what simulation tool you are using, no matter what kind of computer-aided engineering tool you are using. You know, advanced technology industry are using CAE, CAD, CAD-CAM for a long time. So
fully underlined, yeah?
Yeah, so for general industry, if we can do this, I hope we can welcome the
Yeah.
much better world together.
Yeah.
Okay.
Absolutely. So thanks for sharing this perspective. I think it's a great summary of everything, but also what we have spoken. One aspect I would like to touch on, if I understand you correctly, thinking of scale. Yeah. If I think of, I've seen a great example of Hyundai Heavy Machines. Yeah, with the vessels. This example was more than 7 million parts. Yeah. So it means we are really ready also to serve not small projects, but really large-scale engineering projects, right? So real-world complexity. Is this correct?
Yeah, so this is the transformation we're on, right? So before, we need to transform this to the cloud. We need this accessible on every iPad, desktop, everything else, right? We need to be able to enable people to do that. Before, we were always constrained, right? Because you were based on what you had on your desktop. Now we're unlocking that, okay? And I think that's what you're starting to see with this next generation of technology that we're working with AWS and NVIDIA to do, is to actually make this accessible in the cloud. If I look at the bill of material for a ship, it's 7.5 million BOM lines. It's a lot of parts, right? And so the cloud enables us to do that. If I look at a desktop, you probably do 100,000 parts. It would be a huge bill of material on a desktop. Now we need to transform. But then it's not just the ship, as you saw. It's the ship in context of its scene, in a shipyard. And I need to be able to manage that shipyard on top of that. And then that shipyard sits in a position in the world. So this thing grows very fast. And this is what we need to be able to work together.
And I think to your question, yes, we can really go big now, right? And that's the perfect example for that from my perspective. Now, if we look across the industry, right, there are other players out there which are probably not that big, right? There are very clear use cases, big, go for it, do it right now. For smaller players, think about where is the right starting point, right? You don't need to go big like this shipyard and the ship, right? No. Where is the actual benefit for you? Start with a small part of your factory, with a machine, with a production line, right? This is where you should look into what do I have available also today, right? What kind of CAD data do I have that I can tap into? What kind of different data sources do I have that I can combine, right? That's important to think about. And then also bring your teams together, right? It's not about here's the team, they do everything, right? It's really a cross-functional approach. And you need to think about what's the right starting point. It's a journey, right? It's not okay, let's do a 6-month Industrial Metaverse project, done, check mark. Yeah. It's going to be somewhat similar like digital twins, right? We're discussing digital twins since 30 years, right? Yeah. Now is the time to start thinking about Industrial Metaverse. How do I leverage that? Where are the first use cases? And then this is going to evolve over time.
Yeah. Sorry.
Yeah, no, I'd like to also mention the cultural aspect of the transformation, right? So probably there are two forcing factors that are helping in the acceleration in this historical moment. One was pandemic that obliged us to think that teams are virtual. You have global teams everywhere. You want them to access the same data at the same time to collaborate and leverage the collaboration. The second aspect is that basically there are newcomers into I would say one of the most conservative industries, which is manufacturing, right? Think about gigafactories or companies that are entering the market now. They say, okay, I want to go cloud first for the plant and such, and are forcing legacy providers to say, okay, there's a new threat coming in. How do I accelerate? How do I use technology? And this requires really a cultural change where all companies can, and also the BCGs of the world, help legacy players to accelerate and jump into something which has a risk, into an risk-adverse market.
Got it. Matt, you really applied it. You worked with it. From a capability point of view, do we need new capabilities to work with the industrial metaverse, or can we rely on existing capabilities? What is your experience in your lab when you approached it for the first time?
Yeah, from our experience, I think there is one thing is very important. It is important to demonstrating tangible result in each in critical stage. So I think we just need to build 3D modeling. We can do some application, adding some complicated physical simulation. We can do more application. I think it's a journey to combine digital twin and AI. It's very important. Okay. Thanks.
I would again open up for another question. Please.
Thank you for such insightful discussion on my favorite topic as a student.
We can't hear you.
Oh, thank you for such insightful discussion on my favorite topic as a student. Regarding the last point you made on collaboration within companies, I wanted to know what factors influence the companies, like your respective companies, for the collaboration and investment for the industrial metaverse integration on the same platform. So what are the more important, like whether it's a market potential alignment with the strategic goals, or whether it's the regulatory or concerns, or whether it's data leveraging? So maybe you can rate.
I can start, but so if I look at I would say it's easy when you come from the Amazon culture, which is being customer obsessed. So our first leadership principle is customer obsession, which means really starting from a real need and then work backward to the technology. So this is basically where you need to spend time with customers to solve the real business problems and such. Now, in terms of, if you look more at the, let's say, corporate strategy and such, if you can identify durable needs in the time, no matter what the technology is in that moment, the durable need will stay. I go out for manufacturing, but take the Kindle, the ability for a customer to have any book in 60 seconds everywhere, it's a need that will stay, let's say, forever. And the hardware itself, the technology itself is changing, but that need is, so if you can, let's say, identify a long-term durable need, no one will say, I want my OEE to get worse by time. I want to spend more with my productivity. No, those are durable needs. And then leverage the best technology there to help customers to achieve this.
Excellent. Maybe we spend the last 5 minutes on looking a little bit into the future. So whom of us could imagine what's doable today if we look 5 to 10 years back, right? So trying to look 5 to 10 years ahead of time. What do you think? Can we expect something like a ChatGPT moment for manufacturing? So really like revolutionize, so the way how ChatGPT also impacts a couple of business processes in the IT world. What can we expect on the shop floor?
So I think AI will play a big role, definitely, right? I think it will play a big role around optimization, okay? You'll be able to walk into your plant in the morning and say, how will my plant do? I need to optimize something. And it'll go and calculate and work out all the ways to optimize your plant, right? So we're working on this now, right? We've got large language models now to help us with design. Or I say, I have an issue with a clamp that holds a battery, for instance. I can now just go online and say, optimize this design for me. Make it lighter, stronger, whatever else. So this automation that's coming to help optimize and improve is really going to be. And as we get more and more automated, lights out plants and everything else, it's going to be critical to keep that optimization. And the other reason why optimization is required is people want more flexibility. So I want to be able to have flexible manufacturing. And when I do flexible manufacturing, it's hard to optimize because everything's changing always. So this is the layer that's going to come on that's really going to help in the next 5 to 10 years, in my mind.
Fully agree. Everything will be AI infused, right?
Yes.
There's no way around that. We see that today, right? Generative AI is already there and helps to better understand like what's going on the shop floor. Like today, it's more tapping into still some high-level data, right? But in 5 to 10 years, I would expect that this goes way deeper. Like you said, helps you really optimize also, right? There is no way around that. And I think similarly, like we discussed around the industrial metaverse, the AI tools will become a part of your daily work, right? Synthetic data generation, right? To further optimize your design, to develop your factory to the next level, your product, right? This is going to be part of every workflow.
And the intelligence actually being pushed also right down to edge devices, right? HEVs are becoming really smart. We're putting high-end NVIDIA chips in our AGVs so they can become intelligent. They can be self-aware. You can tell it, here's a process, please go and complete it. That's the level that we're going to.
Matt, where does the industrial metaverse bring Delta Electronics in 5 to 10 years?
Yes, I think in 5 to 10 years, more and more human tasks will truly be assisted by AI. So we need some solution combine digital twin, AI, and large language model. Yeah.
Maybe if you look at the hardware side, there is already a clear trend that some hardware in the plant will disappear, like soft PLC is one example, right? So this is really due to the fact that the hardware cycle and software cycle are totally different. If you can move as much as possible software, you have better cycles and faster cycles. And then again, if I look at new plants coming, they are trying to minimize the IT power in the plant and move as much as possible in the cloud because it's more efficient, more sustainable, more cost effective. On the workforce side, I think there's a new generation coming with digital skills, so plants will need to be digital to retain talents and upskill existing workforce. We need to automate the repetitive tasks where humans are not adding value. They will be taken on by robots. At the same time, the technology will augment the human capabilities. They won't disappear. We'll still need humans, but leverage the technology, they will do a better job. And finally, I think there is a trend due to several factors, but reshoring, smaller plants, more flexible. Think customers like Northvolt, the ability to create easily replicable small units, which again, it's the trade-off between standardize and optimize, but I think we will see new players in the space basically reinventing the way we do manufacturing.
Perfect. I think there will be exciting times ahead of us. So hopefully you could understand a little bit better what the industrial metaverse is. Please keep in mind the industrial metaverse has a transformative role. So it can really change. It's not only a question of technology, it can really change the way of working. It can change the way how we collaborate and also enables things which we couldn't do in the past. Therefore, I highly invite you, together with your partners of choice, actually to shape the world of manufacturing together. I would like to thank you, all of us, Stuart, Timo, Matt, and Max, for taking the time today morning and sharing your perspective with us. Thank you very much.
Thanks, Steve.
Thank you.